Hi, good morning, everyone. That good morning wasn't intense enough. Good morning, everyone. You didn't tell good morning. Good morning. What are we doing today? Physics. Oh, physics. Nice. Right. Right, guys, we started with electric field. Just started with electric field. Is it? Am I right? Just started with electric field. Give me something. Right. So, what is an electric field? Is a region in space where a charged particle will experience a force. Okay. Simply, if I keep a charge here at this point, and if it experiences a force, that means this point is an electric field. There is an electric field around. If it doesn't experience a force, that means there is no electric field. Okay. An electric field is a region in space where a charged particle will experience a force. Then we spoke about what is an electric field strength. Electric field strength is denoted by E. Do you remember what is gravitational field strength? What's gravitational field strength? The force acting per unit mass in a gravitational field. So electric field strength is the force acting per unit positive charge in an electric field. Am I right? If you leave a 1 coulomb charge, how much that charge will be experienced in the force? The force that charge will be experiencing is what you call the electric field strength. Correct? So the force is measured in what? Newtons. Charge is measured in what? Coulombs. So the electric field strength is measured in what? Joules per coulomb. Sorry, newtons per coulomb. Force per unit charge, so newtons per coulomb. So that is what we have done. Let's continue from there. Right on the next subtopic, Coulomb's law. Coulomb's law. Coulomb's law. Right. Right. There's a Coulomb's law is about the force acting between 2 point charges. Okay. You know from your small days, when you leave 2 positive charges next to each other, they will attract, no? They will repel. There will be a repulsive force between them. But if you leave 2 negative charges together, they will attract, right? No. Why? They will repel. But if you keep a positive charge and a negative charge, they will attract, right? Yes. Why? Opposite charges attract. Right. Opposite charges attract. Okay. And like charges repel. You want. By the way, it's not Mike. It's Mike is someone's father. It's supposed to be Mike. Mic is a shortened form for the microphone. Okay. Listen, so guys, like charges will attract and like charges will repel. Either way, there's a force between them. Either attractive or repulsive, there will be a force. So this Coulomb's law is about how much force is acting between them. So the Coulomb's law is about that. So what does that say? Coulomb says when there are 2 point charges, the attractive force between them, let's say this charge is Q1 and let's say this charge is Q2 and let's say the distance between them is R. Okay, let's forget about what Coulomb told. Use your common sense and tell me. Because if you bring these 2 charges close together, will the attractive force or the repulsive force, when you bring them close together, will it be more or less? More. When you bring them closer, the force will be more. Great. Coulomb also told the same thing. Okay. When you bring it closer, the force is more. Let's say you increase the 2 charges, you make the Q1 and Q2 bigger. You're not changing the distance. You make the Q1 and Q2 bigger. Then the attractive or the repulsive force will be more or less. More. Coulomb also told the same thing. Okay. Actually, if Coulomb hadn't told that, we could have told that. So what's Coulomb's law? The force between 2 point charges is directly proportional to the product of the charges. Directly proportional. And inversely proportional to the square of the separation between them. So he says, F is proportional to Q1, Q2. F is proportional to the product of the 2 charges. Higher the charges, higher will be the force. And then he also says, F is inversely proportional to the square of the separation between them. So higher the R, lesser will be the F. Lesser the R, higher will be the F. But he brings this square proportionality. So if it becomes F is inversely proportional to R square. So if you put both of them together, we can come up with a inequality like this. F is proportional to Q1, Q2 over R square. Okay. That becomes Coulomb's law. Right under that. Coulomb's law. The force between 2 point charges. The force between 2 point charges is directly proportional. Is directly proportional. Is directly proportional to the product of the charges the product of the charges and inversely proportional to the square of the separation between them. To the square of the separation between them. Okay. Right. Draw this one and take this down. So F is proportional to Q1, Q2, and F is inversely proportional to R square. If you put the 2 proportionalities together, it becomes F is proportional to Q1, Q2 of R square. That is F equals 1/4 pi epsilon naught Q1, Q2 of R square. So guys, the proportionality constant is 1/4 pi epsilon naught. Take one. Only get it. Only get it. Got it? Okay. That is the law. It's the law. You fine? Yeah, see. You can't question it in the sense, no, the laws, they would have done it for experimented for years and years and they have come up with it. So we can do an experiment and verify it. Okay, but how he came up with it, that is by experiments. Right. So guys, this proportionality constant is 1 over 4 pi epsilon naught. So 1 is constant, 4 is constant, pi is constant. That epsilon naught, this one, this epsilon naught is known as the permittivity of free space. What is that? Permittivity of free space. So in your calculator, you can find a constant. It may be the constant number 32, I guess. Let's say epsilon naught 32. Yes. As a calculator. No. Guys, check for the constant number 32. What is the value? 8.85 into 10 to the power minus 12. So the value of epsilon naught is the value of epsilon naught is 8.85 into 10 to the power minus 12. What is the unit? Farads per meter. Fm minus 1. Farads. You know farads, right? The unit of capacity. Farads per meter. So that is epsilon naught. So then we can get 1 over 4 pi epsilon naught at once. This will be 8.99 into 10 to the power 9 meters per farad. Take down both. Write down a question. Two-point charges of charge 2 coulombs and 5 coulombs. 2 coulombs and 5 coulombs are separated by a distance of 0.5 meters. Full stop. Calculate the force between them. Calculate the force between them. Give it a try. What's your answer? 3.6 into 10 to the power 11. The 104 epsilon naught, straight away you can use it as 8.99 into 10 to the power 9. And the two charges are 2 and 5. So 2 into 5 divided by 0.5 square. 3.6 into 10 to the power 11. Correct? Okay. Right. Here's the next one. Where's another one? 2 point charges of charge 60 microcoulombs. 60 microcoulombs and 2 millicoulombs are separated by a distance of 2 centimeters. Separated by a distance of 2 centimeters. Full stop. Calculate the force between them. Guys, what's the answer? Right. What is the answer? Two point seven 10⁶ newtons. So guys, microcoulombs, you have to convert it to coulombs by multiplying by 10⁻⁶. So it will be 16 10⁻⁶. Millicoulombs to coulombs, it will be 10⁻⁻3. No, 2 into 10⁻⁻3. So 2 centimeters in meters is 0.02. So 0.02 square. You get the answer. Is that okay? And someone has asked me how to get that constant in the calculator. Whereas in the calculator cover, the lid, there is a, your cal doesn't, I don't know, not every cal, certain cals have. If you have this calculator, you have it. And what is that model? Madam, what is the model number calculator? No, model number. Yeah, FX991EX or ES or EX plus or anything that you're having. In the cover inside, there is a list of constants. Okay, in case if you didn't know. So guys, there is a constant number for each constant. So in the calculator, if you press above number 7, you can see it says constant. So shift number 7, then they will ask you what is the constant number. If you put that correct constant number, you will get the value for that constant. Okay. Where's your lid? Yeah. No. No means no only. But anyway, nothing to worry. Don't worry. These values are given in the paper. So if you have it, this will be a bit convenient. But otherwise, you can take the value from the paper. It will be there in the data sheet. Right. Question 3. Let's draw this diagram. Okay. Draw this diagram. Coding, get the tube. Put your hands up. Coding. Did you get it? Right. Guys, there are 3 charges A, B, C. A is a negative charge, 20 microcoulomb. B is a positive charge, 80 microcoulomb. And C is a negative charge. C is a negative charge, 53 microcoulombs. And the distance between them, between A and B, it's 10 centimeters. Between B and C, it's 15 centimeters. Okay. Well, the question is, calculate the resultant force acting on B and its direction. Okay. Calculate the resultant force acting on B and its direction. Right, guys, I'll give you a small hint for you to start off. Now, since A and B are opposite charges, A will attract B this way. Okay, we'll take it FA. Again, since B and C are negative charges, C will attract B this way. Correct? So we'll find the FA and FB separately and get the resultant of that. And the direction will be in the direction, depends on whether FA is greater or FB is greater. Correct? Can you find FA and FB separately? Sorry, not FA and FB, FA and FC actually. What's the answer? What's the force? 255 newtons. 255 newtons. Are you sure? Correct. 255.7 newtons to the right, towards C. So guys, we can find the FA by taking the charges A and B. So it will be 104 pi epsilon naught is 8.99 into 10 to the power 9. Charge of A 20 into 10 to the power minus 6 into charge of B is 18 into 10 to the power minus 6 divided by R square. R is 10 centimeters, that is 0.1 meters, 0.1 square. There you get FA. Okay. Similarly, you find the FC. I'm getting 1694.1. So the bigger one is FC. So definitely the resultant will be towards C then, to the right, as per the diagram. So which means the resultant is the difference between the two forces, 255.7 newtons to the right. If you have any questions, you can ask. Okay. The results coming on 17th or 18th? 17th. Right, just start. What is the day? Thursday. 17th.
So we can't unmute by ourselves, sir.
Huh?
We
Then
can't
how did you
unmute by
unmute
ourselves.
now?
You just
How did
unmuted me.
Huh?
You just unmuted me.
Okay, now try to unmute. Can you unmute now? Hello? Hello? Bro, are you there? Oh no.
So someone has changed the settings.
Yeah. Because there are some students are very painful now. I mean, I didn't tell it's you. Okay. So maybe because of that. Okay, now you're happy. Yusuf, do you have any questions? Hello? Again, Nika? I muted by mistake. Okay, then let it be. Right, guys, the next one. Guys, you know now what is electric field strength? The force acting per unit positive charge. Okay. Now, in an electric field, now let's say for an example, the electric field is this way. There is an electric field this way, in this direction. Okay. Then if we leave a positive charge in this field, what charge? Positive charge. It will experience a force in this direction. Okay. In the same field, if we leave a negative charge, what? It will experience a force in the opposite direction. So remember, in an electric field, the positive charges will experience the force in the direction of the field. Okay. The negative charges will experience the force in the opposite direction to the electric field. Okay. Let's make a note on that. The direction of the force on a positive charge the direction of the force on a positive charge the direction of the force on a positive charge in an electric field will be in the same direction as the electric field. In the same direction as the electric field. Can you draw the diagram? And then below that mention that on a negative charge, the direction of the force will be opposite to the electric field. Right. Let's write another question. A force of 24 newtons acts on a charge of 8 coulombs in an electric field. Full stop. Calculate the electric field strength. Okay. What is your answer? 3. Yes, of course. Electric field strength is the force per unit charge. So E equals F/Q. So 24 over 8, that will be 3 newtons per coulomb. What is the unit of electric field strength? Newtons per coulomb, and there's another unit also. Volts per meter. Right. Then wait. Calm down. Right. Here's question number 17, part A. Question number 17, part A. Yeah, we'll do it together. A point positive charge and a point negative charge are placed 8 centimeters apart at point X and Y. calculate the magnitude of the electric field strength midway between x and y. The charge at x is given, charge at y is given. X is a positive charge, y is a negative charge. Guys, don't do, just look at me, look at the screen. We want to find the magnitude of the electric field strength midway between x and y. So we are talking about a point somewhere here. We shall take that point as what? Is it z? Happy? X1. So guys, the distance from x to z, this is how many centimeters? Huh? 4 centimeters. Z to y is 4 centimeters. Z is the midpoint between x and y. Now use your common sense and tell me. Okay. Now guys, there are 2 point charges, no, x and y. Okay, first think about what is the definition of electric field strength. The force acting per unit positive charge. Okay. Now guys, forget about the y for a moment. Forget about the y. Due to this charge x, okay, due to the charge x, what will be the what is the direction of the electric field strength at z? Right or left? Right or left? It's right. You're telling right. Can you explain all the other dumb why it's to the right? Tell it again. Yeah, that's correct. Or you can think of it like this, guys. Now, electric field strength means the force acting per unit charge on a positive charge. No? So now, if you are at any point, if you are confused, what is the direction of the electric field strength at z? So imagine that there is a +1 coulomb kept at this point at z. If a +1 coulomb kept at z, tell me that 1 coulomb will experience a force to the right or left due to this charge x. To the right. Because it's a positive charge, no. Since x is a positive charge, due to the charge x, if you leave a +1 coulomb at z, there should be a repulsive force. No? So that means that 1 coulomb will experience a force to the right. Am I right? So which means the electric field, listen to me, electric field strength at z due to x is to the right, Ex. Okay. Correct? Now forget about x. Forget about the charge x. Okay. If you forget about this charge x, due to the charge y, what is the direction of the electric field strength? X. Right or left? Right. That is also to the right. Y. Because now y is a negative charge, no? So if you leave a +1 coulomb at z, the negative charge will attract the positive charge. Am I right? Agree? So which means the electric field strength at z due to x is to the right. Electric field strength at z due to y is also to the right. Am I right? Agree. Yeah, but darling, the definition of electric field strength is the force per unit positive charge. So if you want to know what is the electric field strength at Z, you should imagine a positive charge plus 1 coulomb charge kept at that point. Which way will that force experience? You get it? So stick to the definition. Electric field strength means how much the force acting per unit positive charge. Correct? So due to both X and Y, the electric field strength is to the right. So the total electric field strength at Z will be, if I take it as E, that will be EX plus EY. Am I right? EX will be, because electric field strength is given by what? Force per unit charge? No. 1/4 pi epsilon naught Q1 Q2 of R square. No. So one charge is 1 coulomb. So Q1 into 1 over R square. Okay. So which will be, EX will be 1/4 pi epsilon naught. The charge X is how much? 2.5 into 10 to the power minus 7. Into charge at Z is 1. Over the R is how much? 4 centimeters, 0.04 square. Correct? That plus, again 1/4 pi epsilon naught. Again 2.5, because it's the same charge. Again, Y is also having the same charge. 2.5 into 10 to the power minus 7. Into R. Into 1 over R square, which is again 0.04 square. Because the distance between Z and Y is also 4 centimeters. Is that okay? This will give you the total electric field strength at the point Z. Any questions? Any questions? Understood. The Q is 2.5 into 10 to the power minus 7. No, I'm using E equals F over Q. The force per unit charge, right? So the F is 1/4 pi epsilon naught Q1 into Q2 over R square. This is the F, right? So for that F only I have taken, listen. So EX means the force acting per unit charge. So now imagine here at Z there's a plus 1 coulomb. So the force acting on that is what you call the electric field strength, right? So I have imagined a plus 1 coulomb at Z and use the same equation. So which is 1/4 pi epsilon naught. E charge 1, X is 2.5 into 10 to the power minus 7. The charge at Z is 1. Over the distance is 0.04 square. So that will tell you what is the force acting at point Z when you keep a plus 1 coulomb charge due to the charge X. Similarly, on the other side, Y. So X is exerting a force on plus 1 coulomb kept at Z to the right. Y is also exerting a force to the right. So the resultant electric field strength at Z will be the addition of the two. Done. Take it down and find the value. Yeah. Correct. Charge of X I have taken 2.5 into 10 to the power minus 7 here. Okay. Now, electric field strength means the force acting on a +1 coulomb charge. So if you place a +1 coulomb charge here, and if you find the force acting on it, that is the electric field strength. Yeah. Again, dividing by +1 means the same thing. No? Get it? We take only the magnitude of the charge. Even though y is negative charge, when you put it into the equation, you take only the magnitude of the charge. Sorry? Yeah. Yeah. Sign is different mean? Yeah, that's what we have in. Any questions? Have you got this answer? 2.81 and 10⁶ newtons per coulomb. Guys, write down the subtopic. Electric field strength due to a point charge. Electric field strength due to a point charge. Okay. There's no harm. Electric field strength due to a point charge. Guys, now listen to me. Now, let's say there's a charge Q. Okay. and at a distance r, let me say there's another charge, simple q. So I'll take the force on this to be F. It can be either attractive or repulsive. Just in the diagram, I have marked it attractive, but it can be either attractive or repulsive depending on whether they are like charges or unlike charges. So now I'm going to come up with an expression, an equation for the electric field strength at a distance r from a point charge q. From a point charge q at a distance r, what will be the electric field strength? Okay. Now guys, if I take the force acting on this one, if I take it to be F equals 1/4 pi epsilon naught into Q over R square. Am I right? So on this charge, simple Q, the force acting is 1/4 pi epsilon naught Q over R square. So if I take F divided by simple Q, okay, 1/4 pi epsilon naught into Q over R square. Okay. Yes. Can you tell me what does this mean? F over Q means what? The force per unit charge, right? F over Q means at this point, F over Q means at that point, how much is the force per unit charge? Agree? F over Q, force over charge means force per unit charge at this point. So what is force per unit charge means? Electric field strength. So what does that mean? The electric field strength at that point. So the electric field strength at that point is equal to 1/4 pi epsilon naught into Q over R square. Okay. So due to a charge Q, at a distance R, the electric field strength is given by this equation, which is 1/4 pi epsilon naught Q over R square. Is that okay? Right? Check it out. Okay. Right, guys, write down the question. Question 1. Calculate the electric field strength. Calculate the electric field strength at a distance 5 centimeters. At a distance 5 centimeters from a charge 20 millicoulombs. From a charge 20 millicoulombs at a distance 5 centimeters. Calculate the electric field strength. So guys, the electric field strength will be 104 pi epsilon naught Q over R square. How much is 104 pi epsilon naught? 10 to the power 8.99 into 10 to the power 9 in SI units. Q is 20 millicoulombs. That's 20 to 10 to the power minus 3. We are talking about a distance 5 centimeters away from the charge. 5 centimeters is 0.05 meters. 0.05 square. And that is, come again, 7.192. I'll take it as 7.19 into 10 to the power 10. Newtons per coulomb. Is that okay? Are you getting this answer? Okay. All right. There's question 2. Draw this diagram. Okay, let me elaborate the diagram a bit. A is a positive charge, 50 millicoulombs. B is a negative charge, 40 millicoulombs. And the distance between A and B is 20 centimeters. And the point P is in between them, which is 12 centimeters from A. The question is, calculate the electric field strength at P. Calculate the electric field strength at P. Right, guys, tell me this. Electric field strength at P. Listen to me, just answer this part. Electric field strength at P due to A, to the right or left? Who told left? To the right. I'll take that to be EA. Electric field strength at P due to B is to the right or left? Right. I'll take it as EB. Correct. So that if there's anyone having a doubt with that, please put your hands up and ask me. Any questions with that? How to decide the direction? Yeah. All you need to think is, my dear darlings, listen. Imagine there's a +1 coulomb at P. If you have kept a +1 coulomb at P, due to this positive charge at A, the +1 coulomb at A, P will experience a repulsive force, which means the force is to the right. Similarly, due to this negative charge at B, on this +1 coulomb at P, there will be an attractive force. Okay, it's based on the simple theory, like charges will repel, unlike charges will attract. So due to the negative charge at B, the +1 coulomb kept at P will experience a force to the right. So which means both EA and EB both are to the right. Right? Do you still have a question? So now we find the EA and EB and get the addition of them. That's going to be the answer. Right? So EA will be 104 pi epsilon naught uh 50 millicoulombs, 15 to 10 to the power minus 3 over the distance between A and P is 12 centimeters, which is 0.12. That square. That will give you the EA. Similarly, we can get the EB. EB will be EB will be 104 pi epsilon naught Q over R square. There's now P to B, what is the distance? P to B, 20 minus 12, 8 centimeters. So it will be Q is 40 millicoulombs, 40 into 10 to the power minus 3 over R square. The R is 8 centimeters. 8 is 0.08 and that square. Can you please tell me AEA is how much? 3.12 into 10 to the power 10 to the power 10. And the EB is 5.62 into 10 to the power 10. So the total electric field strength will be EA plus EB. 3.12 10 to the power 10 plus 5.62 10 to the power 10, which is 8.74 into 10 to the power 10 newtons per coulomb. Is that okay? Any questions? We added them, Yusuf. We added them. The difference is that I took it separately and then added them. Okay. Right, guys, write down the next question. So there are 2 point charges A and B now, but now this time both are positive. Okay, both are positive, and A is having a charge of 80 millicoulombs. B is having a charge of 50 millicoulombs. And the point P is between A and B. A to P is 5 centimeters and B to P is 10 centimeters. Now we have to find the electric field strength at P. Calculate the electric field strength at P. Right? You tell me. Okay. You tell me. Due to charge A, the electric field strength at P is to the right or left? To the right. Due to charge A, the electric field strength is to the right. I will take it as EA. Due to charge B, the electric field strength at P is to the right or left? To the left. I'll take it EB. Is everyone okay with that? Correct. So guys, now we'll find the EA and EB and we'll get the difference of the two. Okay, now we can't add them. The resultant electric field strength at P has to be either EA minus EB or EB minus EA, depending on who is bigger. Okay, can you? Okay, here we use this equation to find the electric field strength. The Coulomb's law equation Q1 Q2 over R square, that is to find the force between two charges. This equation is to find the electric field strength at a point. Guys, what is EA? 2.87 into 10 to the power 15. You didn't convert the meters to centimeters, centimeters to meters. EB? Which is 2 point? 4 point? Give me two decimal places. 4.50 into 10 to the power 10. So now, which is bigger? EA. So the electric field strength will be EA minus EB. How much is that? 2.4. Is that okay? Any questions when you are? People online, any questions? Okay, right. Any questions? All right, guys, write down the next subtopic. I don't know how to change the settings. I have to inform the back office. Give me, I'll inform them during the break. You want a what? Break for what? You want a break for what? From physics. Okay, come here. Come and sing a song. Come.
No.
No, that is not physics. No, come.
Why am I going to sing a song?
So that's a break from physics. No, that's music. No. So you are telling all the singers are bullies.
No, I'm saying no. Can't sing, so everyone's ears are open.
Huh?
Can't sing, everyone's ears are
No, no, it's okay. We can do this now. Okay, tell me, Ami, what are your hobbies? Yes. Yeah. What are the interesting things that you do? Getting bullied. Who told that? I don't think anyone likes to do that. Tell me, what are your interesting stuff? Eating. Yeah. What else?
Why are you putting me on the
Ah,
spot?
okay, fine.
Why me?
You are the one who wanted the break. No?
Yeah, I want to break. No,
So this is a break, right? You wanted a break from physics, right? So are you? No, 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 no. You tell me what is your ambition? My life. What do you want? Huh? I was taken to watch.
What did you think about the movie?
I actually, to be very honest, I slept more than half of the I swear. No, for the first entire 15 minutes, all I heard is, "Hi, Bobby. Hi, Bobby." Entire 15 minutes. Then I watched for the first 20 minutes, it was nice. The way how they have done the movie was nice. Then after that, I felt I slept. Yeah. Who else went to watch? Today I'm. You tell me about. Yeah, let's listen to him. You. Tell me about your ambition. You want to?
I have no idea.
Anyone who can tell about your ambition? Anyone? You? You want to be a teacher? Sure. Anyone with a legit ambition?
Sir, what's wrong with you? Say your
Yeah, but I feel like you're trying to bully me now. You? No idea. You? What is your ambition?
So what was your ambition?
My ambition was to become an engineer, and I became one. And then I worked as.
Why did you decide to teach?
It was a super coincidence. It was not in my list at all. Okay, I was forced to do it. Yeah, because someone else had to do it, and he told me no, he can't do it, and he told me to do a class. That's how it started, and then fine, no point talking about it. Fine. Shall we move on to the next subtopic? Electric potential.
Now break, right?
Yeah, wait.
So now my turn. Yeah, okay. Let's do that.
Electric potential. Right. It's nice to have an ambition, but don't be very stubborn with it. Okay. take this line. Don't be too stubborn with it. Because now sometimes now when you were small, your brain, everything was small, okay? Including your brain. So when you were small, you have seen something and now you wanted to be there. Okay? You want to become that. But it might not be the right choice because your brain was too small at that time. Okay? So sometimes as you grow up, guys, you will see, I mean, let's say for an example, okay? You wanted to become a doctor. For an example, okay, you have seen when you were small doctors and you think it's super cool and you want to become a doctor and you think that is life. Fine, that's very good. If you can become one, and if you really like to be one, and if your intentions are clean, if you want to become a doctor, that's nice, really nice. But let's say as you grow up, you see, no, that is not what I really want. There should be a small change. This is not what I like. This is what I like. If you feel like at the right time, my advice is make that change. Okay? Don't be too stubborn with your childhood ambition. Don't think after growing, no. When I was small, I wanted to become a doctor. Being the doctor is the coolest thing. Don't be stupid like that. If your brain is telling you, no, that is not the right thing to do. If you like something else after a point, be flexible with that. Okay? That will definitely take you to better places. Fine. Electric potential. I never told anyone not to become a doctor. Please get it right. The electric potential at a point. The electric potential at a point is defined as the amount of work done per unit charge when bringing a small positive charge from infinity to that point. From infinity to that point. Okay, now listen. So guys, let's say there's a charge Q here. At a distance R, at this point, let's say you want to know what is the electric potential at that point. So electric potential at that point means how much work done when you're bringing a small positive charge, +1 Coulomb charge, from infinity to this point. Let's say the infinity is, for an example, here. I will just draw here. From here, if you're bringing a +1 Coulomb charge to this point, to do that job, to do that work, the amount of work that you need to do, that is what you call the electric potential at this point. Okay. I repeat, the amount of work done in bringing, the amount of work done per unit charge, when you're bringing a small positive charge from infinity to that point. So now, then tell me, what should be the unit of electric potential then? Joules per Coulomb. Why? The amount of work done is joules. The amount of work done per unit charge means joules per Coulomb, right? Okay. You also know another unit for volts. There is another unit, volts. Potential is measured in volts, electric potential. And also joules per Coulomb. So which means joules per Coulomb is the same as volts. Correct, right? Right. So guys, draw this diagram. And the electric potential at that point is given by this equation. V equals 1/4 pi epsilon naught Q over R. Right. So guys, the unit of V is joules per coulomb or volts. So the equation is 104 pi epsilon naught Q over R. Okay. Right. Write down a question. We'll do one and take a break. Huh? Yeah, we'll do two and take a break. He is the one. I wanted to give a break after one. So.
Do all five.
A has a charge of 25 microcoulombs. Full stop. Calculate the electric potential 30 centimeters away from it. Calculate the electric potential. Centimeters away from it. Okay. So guys, it will be electric potential will be V equals 104 pi epsilon naught Q over R. Q is 25 into 10 to the power minus 6 over R is 0.3 meters. Correct? So, what is that? How much is that? Come again, please. 7.5 into 10 to the power 5, either volts or joules per coulomb. Let's do one more and go for a break. Guys, now there are 2 point charges you can see, A and B. Both are positive. Both are positive. A has a charge of 3 into 10 to the power minus 8 coulombs. B has a charge of 5 into 10 to the power minus 8 coulombs. And the point P is in between the two, where AP is 8 centimeters and BP is 10 centimeters. Question is to calculate the electric potential at P. Class will be ending at 11:15 the Sri Lankan time. Okay. Right, guys, now tell me, wait. Now, listen, electric field strength, is it a electric field strength, is it a vector or a scalar? It's a vector. Why? Electric field strength means force per unit charge. The force is a vector, no? It has a direction, no? So the electric field strength is a vector. Electric potential, is it a vector or a scalar? It's a scalar. It doesn't have a direction. The amount of work done per unit charge. Work done doesn't have a direction. So guys, now tell me the electric potential at P. So we have to take the electric potential at P due to A and due to B separate. And after that, do you add them or subtract them or what? Add them. Why? Why? Okay, but your suggestion is to subtract them, is it? Why? You are talking about the electric field strength. Now here we are going to calculate the electric potential. Guys, now listen to me. I think it's better you go for a break and come. This explanation will take some time and you will start cursing me. Okay? Yeah, we will do this after the break. See you in 15 minutes. Huh? Oh. Right, get back to work. Very important. Okay, guys, get back to work. Now listen. Guys, now huh? Now if you have a positive charge here, if you have a positive charge here, at this point, the electric potential will be positive. At a distance r, the electric potential will be negative, positive. If you have a negative charge here, at a distance r, the electric potential will be negative. Why? Is it to match the charge? So simply, if you have a positive charge, due to the positive charge at a certain distance, the electric potential will be positive. Due to a negative charge at a certain distance, the potential is negative. Okay. If it is a positive charge, potential will be positive. The negative charge, potential will be negative. But here is the explanation. Listen to me. Guys, electric potential means, as per the definition, the amount of work need to be done in bringing a positive charge from infinity to the point. So guys, imagine in the first case, in this case, you're bringing a positive charge +1 coulomb from infinity to this point. Now this is +1 coulomb. Here the charge is also positive. Both are positive. Okay. So they try to repel each other. So naturally there is a repulsive force between them. So if you want to bring the +1 coulomb charge, you need to do that extra work and bring it. You understand? There's a repulsive force. The +1 coulomb is experiencing a force away from the charge. And then still you want to bring it. That means you have to do the work. So the electric potential at this point is positive. Okay. In this case, if you are bringing a +1 coulomb charge from infinity to this point, do you have to do a work? No, because naturally they are attractive. These are negative charge. These are positive charge. You just leave it, they get attracted. So you don't have to do a work. The work is done by the field itself. So in that case, the work which needs to be done to bring it to this point, we consider to be minus. Understand? Consider to be minus. So it's very easier for you to remember. Due to a positive charge, the electric potential around that will be positive. Due to a negative charge, the electric potential around it will be negative. So the explanation, the reason is what I just told you now. It depending on the work is done by the field or work is done by an external force. Is that clear? So coming back to this question, since it is A is positive and B is positive, both are positive, you can just add the potentials. So the electric potential at P will be V equals 1/4 pi epsilon naught Q over R, which is 3 into 10 to the power minus 8 over the R is 8 centimeters, which is 0.08 meters, plus 1/4 pi epsilon naught Q is 5 into 10 to the power minus 8. Over the R is 10 centimeters, which is 0.1 meters. So remember, since both are positive, the electric potential that will be the addition of the two. Okay. Take it down. What is the answer? There's no direction. Then it's positive and negative. Yeah. Subtract. What is the value? .87 into are you getting this answer? Right. For now, just take it. Around a positive charge, the electric potential is positive. Around a negative charge, the electric potential is negative. Let's write down the next question. Question 3. No, make a note there. The electric potential at a point due to a positive charge will be positive the electric potential at a point due to a positive charge will be positive. And due to a negative charge will be negative. Around a positive charge, the electric potential will be positive. Around a negative charge, the electric potential will be negative. Right, here's question 3. Draw this diagram. A is a positive charge, 6 into 10 to the power minus 9 coulombs. B is a negative charge, 5 into 10 to the power minus 9 coulombs. P is a point in between such that AP is 5 centimeters and BP is 8 centimeters. So the question is to calculate the electric potential at P. Okay. So the electric potential at P due to A will be 1/4 pi epsilon naught. Q is 6 into 10 to the power minus 9. Over the R is 5 centimeters, 0.05. Since B has a negative charge, the electric potential will become negative minus 1/4 pi epsilon naught. 5 into 10 to the power minus 9. R is 8 centimeters, which is 0.08 meters. What is the B? What is the answer? Final answer. Positive or negative? 2. So 517. 3. Positive answer, right? Any questions, anyone? Guys, this month, the last Saturday, I don't think we will have class. So there will be a cover-up class falling. Okay? No, not tomorrow. I will let you know in the group. Okay? Fine. Guys, write down the next subtopic. Electric potential energy. Electric potential energy. Right. This is something very easy to remember. Yes, now electric potential energy of a charge. Okay, the energy, electric potential energy, that is the energy possessed by a charge in an electric field. So that is very simple. Now you know how to find the electric potential at a point. So the electric potential energy means electric potential at that point multiplied by the charge of that charge which is kept at that point. I repeat. Now let's assume he is a charge. Listen to me. He is a charge. Okay, so can I call you this? Okay, right? You won't get offended, right? Cool, right? This is a nice ball. Now this is a charge. Okay. This charge is, let's say, 100 coulombs. So if you want to find the electric potential energy possessed by this charge, you should multiply this charge by the electric potential at that point. Understood? So that will give you the electric potential energy of the charge. So electric potential energy of the charge is electric potential at that point multiplied by the electric charge. Right under that. When an electric charge is kept in an electric field, when an electric charge is kept in an electric field, it will have an electric potential energy. It will have an electric potential energy. Full stop. This energy is given by the product of the charge. This energy is given by the product of the charge product of the charge, and the electric potential at that point. And the electric potential at that point. Is that okay? Right. And then guys, look at this one. Okay, listen. Now guys, let's say there is a charge capital Q here, and at a distance R, there's a charge simple Q here. Let's say you want to find the electrical potential energy of this simple Q. Okay. Now guys, at this point, the electric potential we know, V equals 1 over 4 pi epsilon naught Q over R. There is electric potential now. Correct? So the electric potential energy of this charge simple Q will be V into Q. There is 1 over 4 pi epsilon naught into Q over R, that is the electric potential, that multiplied by charge. Exactly. So basically the electric potential energy will be 1 over 4 pi epsilon naught Q1, Q2 over R, the product of the two charges over R. Set up. Take it down. Here the E is, here this E is the electric potential energy, not the electric field strength. Here this E means the electric potential energy. Okay, right, let's write down one question. A particle P of charge 2 millicoulombs. A particle P of charge 2 millicoulombs is kept 20 centimeters away from a particle P of charge 2 millicoulombs is kept 20 centimeters away from a 5 coulomb charge. Away from a 5 coulomb charge. Full stop. Calculate the electric potential energy of P. Calculate the electric potential energy of P. What is the answer? 4.5 into 10 to the power 8 joules. Is it? Write down another one. And write for homework. So guys, there is this particle P with a charge 2 coulombs and 20 centimeters away from the charge, there is this point A, and a further 10 centimeters away, there is this point B. Okay. And then write down the question. A particle of charge 50 microcoulombs. A particle of charge 50 microcoulombs is moved from A to B. Is moved from A to B. Calculate its change in electric potential energy. Calculate its change in electric potential energy. You can do this for homework. See you next week. Bye, people. Take care. Have a nice week ahead. And give a try. I will explain this in the next class. Okay. Bye. See you. And if you are not being added to the WhatsApp group, send me a message and get yourself added. About the additional cover up class, I will update in the group. You're welcome. Bye. See you. Take care. Last class we did. Last class is the holiday. Last week. What? I forgot to read, but I will explain you read. Okay, go through the chapter using. Yeah, obviously. Thank you, sir. Welcome. Bye. 28386520. Don't send to someone else. I see you. I see you.